Hello everyone. In the previous video for this AMC12B 2022, I went through the questions from problem 1 to problem 20 at competition speed, so to speak, which was 45 minutes for the first 20 questions. Now that would mean that we are left with up to 30 minutes for the last 5 questions, which is a decent amount of time obviously, but still not a whole lot. Without further ado, we're going to jump into these 5 questions, but maybe we can go a touch more comfortably than the first 20, where we were going at a super breakneck pace. Question 21, we are told that S is the set of circles that are tangent to each of 3 given circles. Now, all the 3 given circles are quite easy to describe, right? The first 2, of course, have a center at the origin, and then radius is 2, radius is 8. This one has a center 5, 0, and the radius is square root 3. Let's draw it, right? I'm tangent to these circles. I can only really draw it and hope for the best. So I'll try to draw a decent looking pair of coordinate axes. I'll draw a big circle. I have a small circle. This looks like a donut. And then, okay, so where is this located? This is located in between here and here, right? It will be located somewhere with the 5 zeros between 2 0 and 8 0. But it doesn't reach either of them, and it's almost the same size as the other circle, so something like that. A bit smaller than the first one. Now, I want the sum of the areas of all circles in S. That means basically I want to know what are the circles and how big are they. Let's try to draw the different cases, right? Now, I'll just call this circle here C1 and call this circle here C2. Why I want to name those two and not the big circle is that obviously all of my circles in S are going to be contained inside the big circle, right? If it's outside the big circle, there is no chance it touches the 2 tiny circles. Now, how things may go would be that it could look like that. Now take note here, I'm going to have symmetry. So when I say I have symmetry, it means that there's one on top and one below. I don't really want to write both of them down. So this first circle touches C1 externally and touches C2 externally as well. I can also have one that touches both of them internally, meaning like that. And then I can have those that are 1 each. So something like that. This one touches C1 externally and C2 internally. And no surprises for guessing that there is another case, which is something like that. C1 internally and C2 externally. Now I get 0 marks for artwork, but I don't think that is the most important thing. The first thing we can say intuitively is that when I say externally, you can agree with me that there's probably only one such circle at the top and then there'll be one below by symmetry, but there are no multiple choices of circle. The second thing is that if we look at it just by symmetry, now focusing on the first case, which is the red circle, I can actually look at it and say that, well, this here, it must be symmetric, right? Because you basically have a donut and then you squish a circle in the donut. So the diameter of this big circle is going to be 8 minus 2, so the radius is 3. And actually the same logic would also apply for the blue one. Right, for the blue one, it is also going to have radius 3. Now meanwhile, we have the yellow one. Now the yellow one actually includes the whole of our donut, which is C1. Which means that, again, I'm not really sure whether I'm drawing this to scale, but the diameter would be now like this, which is going to be 8 plus 2, which is 10, which means that the radius is 5, and likewise for the green one. And of course, by symmetry, there's another set of reflections, which means that your answer would consist of 4 sets of radius 3 and 4 sets of radius 5. Now, if you have watched my earlier video where I talked about the final 5 of the AMC10, I talked a little bit about how we can make some educated guesses. Now, the AMC is both a little bit mean as well as predictably mean. So they will try to trick you into possibly forgetting symmetry. Now, the fact that you may have forgotten symmetry suggests that you can see that there are 2 pairs of answers that are a factor of 2 apart. And I would therefore strongly speculate that one of these 2 would be the answer in the actual AMC. And so you can guess, or if let's say you had some vague idea of this radii that they all look like they are 3 or more, then it means that it's quite easy to tell that the answer is leaning more to 136 pi than 96 pi. It's the kind of silly tricks that you can do to earn yourself a little bit of extra time. Next up, question 22. Nth Amelia starts on the number line at 0 and crawls in the following manner. For n equals to 1, 2, and 3, Amelia chooses a time duration Tn and an increment xn independently and uniformly at random from the interval 0 to 1. During the nth step of the process, Amelia moves xn units in a positive direction using up Tn minutes, and if the total elapsed time has exceeded 1 minute during the nth step, she stops at the end of that step. Otherwise, she continues with the next step, taking at most 3 steps in all. What's the probability that Amelia's position when she stops will be greater than 1? Now, Tn and xn are independent. If let's say that the question were just xn, and I just told you that, okay, you're going to take 3 steps, this is not that complicated. It's still not simple, but it's not that complicated. The problem is we're not entirely sure whether it took 3 steps. But it is rather easy to tell, because how many steps you take is determined by Tn. So this determines the number of steps that you actually take. Of course, this is only 2 or 3, right? I mean, 1 step is from the interval 0 to 1, means you can't exceed 1 minute within 1 step. Now, what's the chance that you take 2 steps? Well, T1 plus T2 ranges from 0 to 2. Excuse me, still have a bit of a cough. One is sitting in the middle. So it's 50-50, right? There's a half chance that you have used up more than 1 minute. Half chance you have not. Now, this has nothing to do with xn. So, if there are two steps, okay, so I don't really write it. Let me write it here. If there's two steps, which is probability now I know is half, the chance that the distance is more than 1 is now the chance that x1 plus x2 is more than 1. Which is still half, right? It is clearly true. Now, the chance that it took 3 steps is also probably 1/2. Now, there's actually a little bit of a trick that we can play here if we look at the answer options. The chance that x1 plus x2 plus x3 is more than 1 is clearly between 1/2 and 1, right? Now we have 3 things, so your chances have improved. But it is clearly not guaranteed that 3 things will add up to more than 1. Now this is probability half and this is probability half, which means that your overall probability is going to be the average of these 2 things is between half and half over 2 and half plus 1 over 2, which is between half and 3/4. That's quite funny because between half and 3/4 means that it is 2/3. Once again, practical methods, right? We want to be able to do these things without having to work too hard. The intended approach to finding this probability would be using a 3D geometry approach, which is to plot your points x, y, and z and get the volume of a pyramid, which we can do, but let's not do that. And instead, let's jump to question 23. Now, x0, x1, x2, and so on is a sequence of numbers where xk is 0 or 1 for each positive integer n. Define Sn to be the... Okay, so this is in binary. Right, it basically means Sn is an n-digit binary number. And we are told that 7Sn is congruent to 1 mod 2 to the n. Okay, I'm not sure what to do with that yet. Let's see what we're supposed to find. We're supposed to find x2019 plus 2x2020 plus 4x2021 plus 8x2022. Now, where does that actually come in? Okay, so first of all, in order to even make 2022 show up, that requires me to reach S2023. So it looks like that. Now, what I care about is actually going to be the 4-digit binary number x2022 to x2019. Now, I realize that because Sn is just adding a digit each time. So it means that if I kind of chop here, X2018 all the way to X0, this is S2019. So what I want, actually, is the quantity S2023 minus S2019, and I want this quantity divided. Okay, so if I subtract them, I basically get 2019 zeros. So this is what I want. Okay, now let me think about how I can do that. Well, actually I think I can just find Sn, right? I can just find S2023 and S2019. Why do I say that? Because Sn, your Sn here is less than 2 to the n. By construction, it has less than n plus 1 binary digits. So it is less than 2 to the power of n. Now, since 7 and 2 to the n are co-prime, it just means Sn is the inverse of 7, which is well defined. Means that it is a unique value. There is no choice available to me. I just have to find what it is. Now, of course, if you don't really know what Sn equals to 7 inverse means, it just means literally that 7 Sn is 1 mod 2 to the n. Now, 7 Sn equals to 1 mod 2 to the n means that 7 Sn is actually equal to 1 plus some multiple of 2 to the n. And of course, since Sn is less than 2 to the n, m is going to be less than 7. And I just need to find out what's the m, which will depend on n. And how does it depend on n? It just needs me to have the correct value of m such that the right hand side is a multiple of 7. So let's list out the values of 2 to the n mod 7. It's very boring because it just goes 2, 4, 1, 2, 4, 1. So in particular, that means that 2 to the power of 2019, because 2019 is divisible by 3, it will be 1 mod 7. And 2 to the power of 2023, because 2023 is 1 mod 3, it will be 2 mod 7. So in this case, 1 plus m times 2 to the 2019 is congruent to 1 plus m, congruent to 0 mod 7, means that m is 6. For this one, 1 plus 2m is supposed to be 0 mod 7, which means that m is 3. And so you conclude that S2023 is just 1 plus 3 times 2 to the 2023 over 7, and S2019 is 1 plus 6 times 2 to the 2023 over 7. No, 2019. Let's write it as 3 times 2 to the power 2020 over 7. Now what did I want? I wanted the difference over 2 to the 2019. So their difference will be the 1 7 cancels out. The 3 over 7 is a common factor. Sorry, 2 to the 4 minus 2 to the 1. So that's 14. That's good. So I haven't messed up because 14 divided by 7, actually this is equal to 6. So my answer is option A. We're almost at 20 minutes, right? So this is actually a regular pace that I'm going at. In fact, we will need to be still a bit faster despite the fact that it may already seem that we're getting quite to the point. Never mind. Question 24. Regular 7-gon, so heptagon, inscribed in a unit circle. What's the sum of the fourth powers of the lengths of all 21 of its edges and diagonals? Okay, so immediately I can see that the lengths are going to be expressible using some trigo stuff, right? Because of my extended sine rule, I could find the lengths of these and write them as a sine of, let's say, 2 pi over 7, 4 pi over 7, something like that. But I'm going to again invoke my intuition, which is that this is 7 squared, this is 2 times 7 squared, this is 3 times 7 squared, this is 4 times 7 squared. I strongly suspect there is a pattern. And so therefore, let me use a bit of what we often jokingly refer to as engineer's induction, which is find a pattern, hope it works. So let me drop down to a triangle, a trigon, a triangle. Now if this is 1, then by anything really, this is square root 3, which means that the fourth power, you will get 9 plus 9 plus 9 is equal to 27. Now 27 is 3 cubed. Of course 3 cubed is not really corresponding to any of these options. None of these options are 7 cubed. This is also 3 times 3 squared, which means that if I had only 1 minute left, I would probably guess C already. If I had another 1 minute left, I'm going to try a square, a 4-gon. So in this case, my diagonals have length 2. So I've got 4 of the square root 2's and 2 of the 2's. Square root 2 to the 4 is 2 squared is 4. And this is 48, and this is 3 times 4 squared. Okay, so at this point, after looking at this, it seems like a foregone conclusion, no pun intended, that the answer has to be 3 times 7 squared. Again, I'll leave you to work out the details, but this leaves us a bit of time to actually look at the last question. Because I can't really cheat for the last question, right? I mean, the last question has 4 regular hexagons surrounding a square. Can't cheat. I can't simplify this down into 4 equilateral triangles surrounding a square. I have to use a hexagon. Oddly enough, I usually find that these things are not so bad. And why it's not so bad is that hexagons are way nicer than heptagons, which is what we had earlier. Because I can find all the angles and they're all going to be special. I'm asked to find the area of the whole thing. Okay, area of the whole thing. Let me just extend this out to form a big square. I think that's what I would like to do. So I extend the area out from the whole square. It means 2 tasks. I want to find the length of the whole square, and then I want to subtract off the area of those corners which I have cut out. The corners consist of 8 of these triangles. So I just need to find the area of one of these triangles as well as the length of the whole square, and I would be fine. So let's see what we can do. Now this length is 1. I drew a regular hexagon around here, which means that this actually should line up. This is, it would extend and hit it down there. The square is of length 1, so that is consistent with what I expect. So I just need to know what is this portion here. Now, I do know how to find the length of this portion down here. This is the long side, not really a side, the side of, I can't really call it a side, this diagonal of my hexagon. In fact, we just wrote down, right? This is 1, 1, this is square root 3, the whole thing. So which means that the side length is actually 2 square root 3 minus 1. Great. Now what else do I have? I need to find the area of one of those small triangles. Now this here is 60 degrees because the angle is 120. This here is 45 degrees because of, well, my 90 degrees being chopped in half by symmetry. So that should be fine, right? I can actually find the length of one more of these and I will be good. So I'll just use my good old-fashioned sine rule to find the length of this diagonal. In fact, I don't even need to use the sine rule. I can just let the height be x or h. Then this would be h, 90, 45, 45. This would be 1 over root 3h from my 30, 60, 90. So h plus 1 over root 3h equals to root 3 minus 1, and then we do a teeny weeny bit of algebra. So h equals to root 3 minus 1 root 3 over root 3 plus 1. And the area of each of these small triangles is therefore going to be half times h times root 3 minus 1. So I'm going to just do this straight up, right? So which means that my area equals to the 2 root 3 minus 1 squared, that's the side length, minus 8 of half times h, which is this thing, half times the height times the base, which is root 3 minus 1 again. It's annoying, but oddly enough, not actually that bad. Okay, so the first one here, this is 13 minus 4 root 3. Okay, so this is 3 minus root 3 minus 1 over root 3 plus 1. Let me just simplify this separately. This is 3 root 3 plus root 3, 4 root 3 minus 3 minus 3, 3 plus 1, conjugate, multiply again, 12 plus 6, 18 minus 10 root 3 over 2. So subtract again. So 13 minus 4 root 3 minus 4 times of this. You get 16 root 3 minus 23, which m plus n plus p becomes minus 4. Okay, so there is an option. Now if we did something like this, I would usually like to do a sanity check. And the sanity check I would do is just to say that, let me estimate how much this is roughly. Right, so 16 times 7 times 1.7 is 27.2. So this is about 4.2. Now if I were to look at this here, this is about 2.4, meaning that the entire square is about 5.76. This is about 4.2. Yep, I can believe that I've sliced off about 1/4 of the space. Right, so I think I can accept that this is a believable answer. Yeah, and that's it. That's exactly 30 minutes in. As you can see, this is not easy at all. So before we end off, again, just a parting note. Know your target for the AMC12 or the AMC10 or any competition you're taking. If you're aiming to finish everything, you are basically doing an entirely different contest from someone that's trying to qualify for the AIME, or for someone that's just trying to get a bit of fun problems to do. So know your target and don't feel too obligated or like mathematically responsible to solve everything in the most mathematically correct way. Save that for the AIME, the SMO round 2, save that for the USAMO, USAGMO, or whatever other more slower paced contest that you are taking. So that's it for my review. Let me know if you have any suggestions or if you see any places where I could have improved. As always, please like the video, don't forget to subscribe, and see you again soon for some more videos on the AMC.